Good morning, or good evening, or good night, whatever the heck time is at your place. Today we are going to learn about matrix, basics of matrix, the geometrical significance of matrix, and basically what I think matrix is significant of. I just said significance 4 times in a row. Great. Anything. Anyways, let's move on. So before I start this video, I'd like to tell you that this will be the first part of the video that I'm uploading. I'll upload the second part as soon as I record it. And I'd like to thank Three Blue One Brown for explaining me this concept. Anyways, let's start. So, what is a matrix? If you ask a physics student, they'll say, well, matrix is a way to represent any form of vector, and vector is anything that has direction and has magnitude. If you ask a computer science student what is a matrix, they'll say, well, matrix is anything is basically a 2D list, or actually a list. We can generalize it as a list that in which you can store values, you can store variables, and whatnot. Maybe even traumas and the fact that you don't have a girlfriend and all that. We can store it in there. If you ask any normal functioning, sane human, what is Matrix? They'll say, well, it's a movie, obviously. Uh, but if you ask me what is a matrix, according to me, matrix is is something that is in the middle ground of a CS student and a physics student, or that matrix is a way to represent vectors. I'll not write the whole thing, vectors, and also to store values. It depends on the context. Anyways, we are going to study mathematical matrix in here. So let's begin. Well, the basics of matrix is that any matrix is represented by alphabetical values. Matrix has a matrix is represented like this. The contents in the matrix are called elements. Horizontal lines are called rows, and vertical lines are called columns. Any mat any matrix can be represented as a rows. We have to write rows into columns in subscript. Keep in mind you'll have to follow this order only as it's a convention. Suppose if I write a 2 cross 3, that would be equal to 2 rows and 3 columns. This is a 2 cross 3 matrix. Now, if I write uh, uh, a 3 cross 3, then number of rows would be 3 and number of columns would also be 3. Such type of matrix where number of of rows is equal to columns is called a square matrix. I had not dived deep into types of matrix as that is a very rote topic and I'm very bored of rote topics. Anyways, such matrices are called square matrices. Alright, keep this in mind. This will be useful in the coming videos. Actually, late in the video. Anyways, so this was all about it. We also have a way to represent elements in a matrix. Suppose I have a matrix of 3 by 3, then the elements would be represented as A 1 1. Suppose my A matrix 3 by 3 is equal. So A 1 1, A 1 2, that is first row, second column, A first row, third column. Let's jump down. A second row, first column. A second row, second column. Blah 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 blah. We follow the exactly the same way or same way of naming in Excel too. So this would not only help you in matrices but also in Excel. Alright, so this was basics about vectors. Let's go to the next part. So matrix as vectors or significance of rows. Till now I've not told you the significance of rows in a matrix. Well, every rows and columns have different significance, a geometrical significance in a matrix. Now, suppose if I have a matrix uh, 2 cross 1. All right, we will not go into 2 cross 2 or 2 cross 3 matrices. I have not explained you the significance of columns yet. However, any vector that is represented in the form of matrix is represented as A into n cross 1, where n or the number of rows actually mean number of of dimensions in that vector. All right. Uh, and number of columns is 1 because I have not yet explained you what is the significance of column. So suppose I have a graph. Let me just take copy of this graph and take it over here. Right. Suppose this guy right here is my origin and I make a vector 3 comma 1 over here. This is my vector. This is my y-axis. This is my x-axis. So this vector v, let's name it v would be represented as 3 comma 3 1 matrix. This is a convention to write the x coordinate on top and the y coordinate on the bottom. Uh, this is how we represent any vector, 2D vector in form of an matrix. Now, um, yeah, this is all about any matrix in the form of a vector. Oh no, actually, any vector in the form of matrix. Now, if we jump over to significance of columns, or how I have named it, square matrix of column. I wanted to keep the video really short, but seems like my iPad, actually my concept has other plans. Significance of column. Yeah. So till now we have learned that the rows in a matrix represent the dimension of the vector in that matrix. Now the columns of matrix represent basis vectors. Basis vectors. What is basis vectors? Well, when we make a axis, coordinate axis, we don't just make it randomly. What we do is we make its axis first, basis vectors first, and then we just extend the basis vectors and we draw parallel equidistant lines according to the basis vectors. This is how any coordinate axis is made. This is why we have I cap and j cap. I cap, j cap, k cap are actually basis vectors that make our OG coordinate axis. Basis vectors. If you can see over here in this axis, if this is our origin, this would be j cap, this would be I cap. If we represent it in form of matrix, it would be represented as 1 0 0 1. No need to be confused. I'll explain you why is this basis vectors represented as 1 0 0 1. So the coordinate of I cap is that I cap is touching in this coordinate axis is 1 comma 0. The coordinates of j cap is 0 comma 1, and according to significance of columns are basically basis vectors. So and we go from I cap to I to from x axis to y axis to z axis, and if we and then to other dimensions. This is the coordinates of x of I cap. These are the coordinates of j cap. All right. Um, yeah. So this was the significance of any vector, any square vector. Why am I only talking about square vector? Because uh, the vectors that are not square, like 2 cross 3 vectors, uh, 3 cross 2 vectors. All right. These actually represent something else, so let's not just dive into that. All right. What I want you to focus on is um, what is what if I change the coordinates of basis vectors? Will my coordinate axis get transformed completely? The answer is yes. Suppose if my let me just erase all of this. Suppose my I cap is now 1, 1, and my J cap is minus 1, 1, then my entire coordinate axis would be changed as if this was the 1, 2, 3, 4 in original axis. 1, 1. This is my I cap, and this is my J cap. Now my entire coordinate axis would be transformed like into something like this. Something like this. Just duplicate it and paste it over here. Can you see it? For me, all of this is quite astonishing. This way you can transform your axis into anything you want. Like literally anything. Let me show you one example. Just after I show you this one. Actually, I'm really excited to show you the results. Let's duplicate this, paste it over here. Hmm. This is a transformed axis in colors red and blue. Origin is still the same. Origin is still the same. Yeah. So now our matrix is literally tilted. And this way, with the power of matrices, we can transform axis. Suppose this would be the last example for the day. If I write my basis vectors as 1, 4, and 2, 3, they would be looking like 1, 4, and 2, 3. This was my original y-axis. Alright, just for clarification, for your ease, this is my x-axis. This is my y-axis. Now, can you see it? Our axes have actually transformed and they are no longer perpendicular to each other as we were used to see it. They have transformed to such an extent and they are no longer perpendicular, no longer recognizable. Just a second, messed up. I messed up over there. No longer are they even recognizable or similar to our original axis. They are so different, amazes me. Yeah, and this is how our axis would look like. I know this is really jumbled and not easy to see, but it is what it is. This is how our axis would look like, and the matrix in which this coordinate axis would be represented in would be 1, 4, and 2, 3. Yeah, yes, that is it. Uh, let's just do a really quick recap about what we have learned in this video. I hope we have learned is that any matrix has horizontal rows called rows and vertical lines called columns. Then the contents inside a matrix are called elements. Then, oh my, I really have a goldfish memory. Just a second. What else did we learn? Yeah, significance of rows. Significance of rows. Rows define dimensions in the vector, and columns define basis vectors. Basis vectors, or you can say the coordinate axis. Columns define the coordinate axis, and rows define the coordinates that basis vectors of those coordinate axis of that coordinate axis has. Wait, I really spoke rubbish. Columns define basis vectors and rows define the coordinates that the basis vectors of the coordinate axis have. Yep. So that's all for today's video. I hope you liked it and see you in the next part.